Hi, everybody. In this video, we're going to go over dilations and writing transformations. So here we have the transformation rule for dilation. So this is the second type of transformation that we learned about. The first one that we did was translation, and this is the second one, dilation. If you remember with translation, we were adding and subtracting, but with dilation, let me tell you, we're going to be multiplying. Do you see that the K and the Y are, the K and the X and the K and the Y are right next to each other. So we're going to be multiplying and dividing in dilation. All right. So let's talk about the parts of this. So first of all, this first part right here is the operation. This tells us that this is going to be a dilation. And K is what we call the scale factor. K is the scale factor. Okay, so here's the catch. If K is greater than 1, then that's an enlargement. Picture got bigger. If K is between 0 and 1, and we write the word we represent the word between with using these symbols right here. So that's what we mean by between. So K is between 0 and 1. That's a reduction. That means it got smaller. So bigger. And then here is smaller. So you can tell from the picture, right, what your number is going to be. All right. So you know whether a picture got bigger or smaller. You can just use your common sense to figure that part out. But before we even get to looking at that part, let's finish talking about this function rule. So as I talked about before, this part right here is the original point, and that's the pre-image. Remember, another name for pre-image is domain. Domain, I can spell, and input, right? And then the second part over here is the image, is the result. What's going to happen is I'm going to multiply every x coordinate by whatever k is, and I'm going to multiply every y coordinate by whatever k is. So that's our resulting image, which is our range, our output. Remember, transformations are functions. Because they are functions, they have a domain and input, and you perform this operation, and then you have a range, which is an output. So first things first, remember I said we can look at a picture and kind of see whether it got bigger or smaller. So let's look at that. Here we have the point B, right? C and A for this triangle. If you notice, the smaller triangle doesn't have the primes, but the bigger triangle does. So remember, the smaller one is going to be the pre-image. So the purple triangle here is the pre-image. All right, because it doesn't have the primes. But the green triangle is going to be the image because it does have the prime. So that means it's the end. This is where we started. This is where we ended. So if I started small and I end big, then that's an enlargement. So this picture was an enlargement. We went from big to small. Excuse me, we went from small to big. Sorry, it's an enlargement. We went from small to big. That means that my K is greater than 1. So we just got to figure out what K is. But we know that it's bigger than 1. So the way we can figure out what K is, we can look at the coordinates. All right, so let's look at B. B is located at -1, 2. And B prime is located at -2, 4. Right, -2, 4. So remember I told you about the scale factor, right? We're going to literally multiply every x coordinate by whatever k is. So what does 1 have to be multiplied, -1 have to be multiplied by to get to -2? And what does 2 have to be multiplied by to get to 4? So in both cases, -1 was multiplied by 2, and that gave me -2. And 2 was multiplied by 2, and that gave me +4. So that means my scale factor has to be 2, right? Because that's what I both multiply both coordinates by to get the image. Multiply the pre-image by to get the image. So, okay. So this is how you would write the rule if that's the case. So D2, K is 2, XY is equal to 2X 2Y. That's how you would write the rule. Now let's do one more thing. Let's make sure that it was dilated by a factor of 2. We knew it got bigger, right? But let's go ahead and check the lengths real quick to see if it got bigger. So as you can see here, the length of this line, and this is slanted, so I can't really get a full, like, without doing the distance formula, I wouldn't be able to get an exact answer. But I can see here that this is approximately 3, and this is approximately a little bit more than 6, right? And of course, I need to get the exact numbers to get that measurement, y'all. But from the approximations that I made here, because, good number sense, I'm just counting the boxes over. All right, so that's 6, and that's approximately 6, and that's approximately 3. 6, 3, that's 2. 6 divided by 3 is 2. That means that this was dilated by a factor of 2. All right, let's go on to the next example. So here in this picture, if you notice, the smaller image has the letter D, has the prime on it. The smaller image does. So that means this is a reduction because I went from big to small. It's a reduction. And if it's a reduction, then that means my K is going to be a number between 0 and 1. My K is going to be a number between 0 and 1. All right, so let's go. Let's look at the letter C. Let's look at the letter C. Let's see where that's located. So C and C prime. We're going to look at the coordinates again so we can see what changes were made. All right, so C is located here. Let me find the coordinate by counting. So I'm going to go to the right and then up. So that's 1, 2, 3, 4, 5, 6. And then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the coordinate for C is 6, 10. Now let's find the coordinate for C prime. So that's 1, 2, 3. And then 1, 2, 3, 4, 5. Okay. So once again, let's look at these coordinates again. So 6 went to 3. Think about that, right? And 10 went to 5. So both numbers got smaller, right? So 6 divided by 3, well, to get from 6 to 3, I would have to divide by 2. So dividing by 2 is like a half. So half of 6 is 3. So that means my K is a half, right? So half of 6 is 3. Let's do it again. Half of 10 is 5. So that means my K is a half. So this is how you would write the rule. D 1/2 XY is equal to half of X and half of Y. So, and like we did over here, you can go ahead and check the lengths to make sure, right? So I'm going to check like this length right here, BA. So that's 2. And then if I check the other one, B prime, I'm excuse me, that's like, so AB and then A prime, B prime, right? So that's 4 for AB, and A prime, B prime is 2. So 4 to 2, 4 to 2, 4, half of 4 is 2. Half of 4? No, half of 4? Yeah, half of 4 is 2. So K is 1/2. That's our scale factor. And that's how we do dilation. Now let's look at one more example to make sure we got it. Okay. So I'm gonna pause right here so you can write some things down. All right, so here we go. We have triangle ABC, which has been dilated to create triangle A prime, B prime, C prime. Fill in any missing information. Okay, so in this case, we've only been given the coordinates. All right, and so from the coordinates, we have to tell what happened and what's the function rule. So let's do like we did before. We know that whatever K is, right, is gonna happen to X and it's gonna happen to Y. So let's look at the pattern. So 2 to 6, wait, so 2 to 6, right? And then 1 to 3. So think about that for a second. That means, right, the coordinates got bigger, right? So that means that this is an enlargement. All right, that means this is an enlargement and K is going to be greater than 1 because it's an enlargement. Well, we just got to figure out what that K is. So to get from 2 to 6, I would have to multiply by 3. So 2 times 3 is 6. And then 1 times 3 is equal to 3. So my function rule would be D3, right? Because K is 3. And then of XY is equal to 3X, 3Y. So there goes our function rule. Now let's go ahead and apply that so that we can go ahead and find the new coordinates for everything else. So -1 times 3 and 3 times 3. So -1 times 3 is -3. And 3 times 3 is 9. And then I have -3 times 3, which is -9. And -2 times 3, which is -6. Now, voila, I found all the missing information. And that's how you do that problem. If you have any questions, please reach out. Thank you so much.